Hello, everybody. I think we'll go ahead and get started.
Writing function code to handle bugs. Well, it's a test.
Oh, that's great. Hello, everybody. Thank you for coming to Pyowa. Just out of curiosity, how many people were here last month? All right. So we got a couple first timers. It's good to see. Hope you keep coming back. We've got food and drinks over there. There's more drinks through these doors right here. Bathrooms are upstairs. Wi-Fi over there on the whiteboard. There's also note cards and pens on all the desks. If you have any feedback about anything, suggestions for future meetings, topics, if you would like to present, include some way to contact you on there. If you have any questions about anything, feel free to hit me up or leave it on a comment card. We've got some good topics lined up for the next couple months. So yeah, I hope you come back. And thanks for coming. And I'll turn it over to Grey. And you can introduce yourself and take over. Thanks, everybody.
Awesome. Okay, I think the mic's working. Excellent. My name is Grey Lovelace. Nice to meet all of you. I see some familiar faces, which is awesome. I am one of the consultants here at Source, and in my time here at Source, I have used Python for a lot of our generative AI initiatives that we've been working on, and I've been heading up a lot of those over the past few years. So I'm a little bit of a Python, I don't want to say a convert, but I use it a lot now. So there are upsides and downsides to that, but some of the cool things like Fast API and Pydantic and the things I do like a lot are things that we're going to get to use here. And it really doesn't matter what we're using here, and that's kind of the point of this talk, is we are decoupling a lot of our testing strategy and a lot of what we want to be able to prove our application does from how it's implemented and what libraries we're using. So let's dig in. Behavior-driven development. Who's actually heard that term before? Yeah, a few hands. Excellent. Who's done it before? Okay, and that can mean different things to different people. Yeah, it's totally fine. Just like test-driven development, the name carries a lot of baggage with a lot of people about what that really means. In this case, what we're talking about is my flavor of behavior-driven development. If you went and you looked at the Wikipedia article, it would probably be a little bit different from what I'm talking about tonight. If you went and you asked literally anyone else, it's probably a little different from what I'm talking about tonight, and that's totally fine. That's expected in these cases. We have a lot of different people with a lot of really good ideas in the technology space, but what I'm going to be talking about is what I've started to do on a lot of the projects here at Source and what I've started to do on a lot of my personal projects that I've started to see a lot of benefit from. And that's all I can really speak to, so that's what I'm going to give you guys today. So behavior-driven development is kind of an evolution of test-driven development in my eyes that really focuses on, does my app actually do the business job that I need it to do, right? I don't care how it's implemented. It might be a web server somewhere out here doing something else. It could be in Python, it could be in Java, it could be in Kotlin. Doesn't really matter. I want to just be able to know if I call it here, here, and here, and then I check this thing, do I have all the objects I need? It's really what we're looking at. A lot of people have done stuff in this space similar with an integration test or maybe an acceptance test. What we're going to be talking about here is kind of combining all of those into one area. So it's going to be running more at the unit test level. It's going to be a little bit slower, and they are going to really cover everything end to end and function a little bit more like integration tests. Okay? So we'll go over some of the benefits and some of the downsides as we go through it. So of the tenets that I usually try and adhere to when I'm doing behavior-driven development, or what I call behavior-driven development, is that our test cases represent functionality, not the implementation, like I was talking about before. Ideally, you will actually have some kind of written out requirements. I know that's not really always the case in the real world, but you have some kind of business requirements that need to happen, whether those are more technical or whether they're more business focused. In our case, we're going to show some that are a little bit more technical, and we're going to kind of paired program on all of this stuff, or I'm going to program and you guys are going to watch me mistype things for a lot of times. But these are what our requirements are going to look like, and we're going to write tests against those requirements without implementing anything and just see what that's like. But you should be able to directly tie requirements to one to multiple test cases. And that is, there are a few different libraries that are actually like built around this concept. Has anyone used Gherkin before, Cucumber, that kind of stuff? Okay. Regardless of how you feel about them, I've been in not great implementations of those, and I've been in less not great implementations of those. I think they have a lot of merit behind them, but they are really set up to write out plain language requirements and have that translate into code that executes to test those requirements. We're not going to be going that far. We're just going to use comments to do a lot of that stuff and then show the implementation in the test itself. But that's really the ideal. I should be able to take requirements, map them directly to tests, and if those tests fail, the requirement also fails. Make sense? Awesome. The next thing that's really important to me is my test coverage spans all layers when possible. So a lot of the times when you get into enterprise applications, not everything's in like 1 to 2 files anymore. A lot of the times you have a web layer, a service layer, and a broker layer. And I'm using broker in this case to say like I'm calling out to another API or I'm integrating with another service. Maybe that broker layer is an SDK that's working with something else. In our case today, we'll be working with a broker layer that's calling an API, and we'll also be working one with Boto3 doing an AWS SDK call, all right, to DynamoDB. So typically when people set up tests and they're writing tests at their kind of unit test level, a lot of the time what you see is poorly defined units. And those poorly defined units are usually a class. So if I have a class, I have a test class for it. I have a class, I have a test class for it. And that is my nightmare. I've been in a lot that do this, and it's much, much better than having no tests. But what I end up finding is as I go through and refactor my application to do things more efficiently or to do things more in a way that makes sense when you first open it up and you're trying to make things more friendly to newcomers, you end up having to refactor all of your tests. And that is terrible. We would often have tech debt days on some of my teams that I was on, and we would be like, great, this is a 30-minute change for us to refactor and make our lives way better. And it's going to take us a day and a half to fix all the tests. And that is never the equation that you want to have to rub up against there. So we are going to write ours really at the entire application level. That's our unit that we're defining. When you're working with microservices, which a lot of the time we are, and a lot of applications have moved that direction, that's totally fine. And that is typically why you don't see a lot of tests written like this on old code. If you have a monolith, this is not going to work super well. If you have a microservice, the complexity is going to be okay to be able to write something that goes through all the layers. So what I'm talking about more on like a concrete level here is, let's say that we have an app where we have an API call, calls out, does some business logic at the service layer, and then it calls out to an API. If people are writing unit tests for this right now, they're probably testing a lot of the business logic layer, the service layer, but you're not making an actual HTTP call to your app. You're probably calling the handler that like ends up inside the HTTP layer somewhere, right? And then you're not actually making an HTTP call out to the app you're consuming from. You're probably saying, hey, when I go to call this broker layer over here, just don't call the broker layer, instead return this object, right? So in that case, we aren't testing this whole chain. We're testing this guy, the service layer. Oh, that's really hard to see. I'm going to move it slower. The service layer. And then we're testing like a quarter of the web layer and like a quarter of the broker layer. So if I could make a box, the box kind of ends here or starts here and ends here, right? Ideally, using a lot of different tools that are available now and a lot of different, usually Docker options that are available now, you can widen that scope a lot, make actual HTTP calls to your web layer, and then in your broker layer, you can call out to real dependencies behind the scenes a lot of the time and get a lot better validation that the stuff that you're writing is configured correctly and is calling the services that you want to in the right way. Cool? So we're going to see a few examples of that today too. And then down here is really this dependency layer that we're talking about here. Prefer real logic over mocks. So who feels personally victimized by a mocking library? Yeah, I should see a lot of hands going up. If you've ever tried to write a lot of unit tests, a mocking library is your best friend and it's also your worst enemy. Really, ideally, when I'm writing tests here, I don't want to use a mocking library almost at all, if possible. There are certainly cases where you do still have to use it, and we'll talk about what some of those look like. But ideally, you're instead able to stand up different versions of your dependencies that are going to validate what you're doing a lot better. A good example of this that falls on this real dependency category here is, like I said, we're going to be integrating with DynamoDB in our example today, which is an AWS service. In the past, that would be pretty hard to figure out a good way to test it. You would probably just end up relying on mocks. However, now we have a lot of different options available to us, like a Docker container running what's called local stack. And local stack is a Docker container where you can configure it to use a lot of the baseline AWS resources that you're used to interacting with, things like Dynamo, SQS, S3, all of those things, and it's pretty lightweight. It's not going to be like prohibitive to run on different types of computers. So what we're going to do is we're just going to stand up a Docker container with AWS configured to allow us to use Dynamo services. And then our app is just going to interact with that instead of an actual AWS endpoint. And we're going to get a lot of really good benefits out of doing that. However, we're also going to have a couple of downsides that we're going to talk about. One is that typically when you work with tests, everything is kind of wiped clean and is brand new for every test that you run. Once you start adding in outside services like this local stack or other Docker containers, they have their own state, and you're going to have to manage that state just a little bit. That is 100% a downside to this, but it's a downside that has enough benefits to it that it outweighs it 10 to 1 for me. So if you find yourself having to do a lot there and it's complicating stuff and you're not getting the benefit from it, maybe this isn't the approach for you in the particular project that you're working on. But I found that it has always been an equation that I want to do. So that's an example of a real dependency. A fake dependency is when you would basically implement logic that would not do exactly what the service does, but it does enough of what the service does and works in a very predictable way. You aren't writing like, hey, if someone calls with this, do this. That's more in the stubbed dependency area. But a good example of a fake dependency. So like I said, when we're working with AWS services, we use local stack a lot. However, we also have to work with Azure services sometimes. So I'm working with something where we're trying to use an Azure Service Bus queue. There is an emulator for that can work similar to local stack, but it's pretty new and it's pretty slow. So I tried to do it. I tried to do all that state management I talked about, and it added 2 seconds to every test, which is not okay. That's not going to fly, right? So instead, I had to make a fake dependency. And so as for a fake dependency, all I did is make 2 Python classes that said, hey, when I call to get my queue sender from Azure, just return this class, and this class makes a new queue when someone requests one, and then it just has an internal messages array that it appends to or pops off of every time someone wants to retrieve messages from a queue. So in reality, it's a fancy wrapping around a Python array, but it's behaving exactly like my app needs it to emulate how Azure Service Bus queues would work. So you've implemented logic that doesn't do everything it does, but it does everything your app needs it to do. And then stub dependencies and mock dependencies are things you've probably used before. Stub dependencies would be a little bit of logic that says, when I get this, return this. You do that for APIs a lot of the time. You'll have like a whole directory of like, hey, if someone calls this URL, return this predetermined payload type thing. That's a stub dependency that people use a lot of the time. And then mocking is in a test where you basically say, don't actually call the logic here. I'm going to give you a fake object. And then I'm going to say, when you call this thing on this fake object, it returns this. So it's as far away from reality as possible. I spend a lot of time on this because a lot of people say like, hey, this is real, or this is fake, or this is stubbed. And it gets a little bit pedantic sometimes. Really what we care about is how close to the real thing is it, or is it executing based on logic, or is it executing based on like predetermined requests coming in? Make sense to everybody? Cool. All right. So all of that said, with these 3 tenets of requirements to test cases, coverage spanning the entire length of your application lifecycle or chain as possible, and then preferring real logic over mocks, we should get to this, the kind of the holy grail here, which is your tests should only need to change when one of two things happen. Either when your consumer contract changes, and that can be something like you updated to need more business logic, right? So if this happens, this different thing should happen. That's a consumer contract changing. Or maybe you changed an API and someone needs to send in something new, or you changed an API and there's a new optional field. All of those things are consumer contract changes, things that your consumer would actually need to be aware of when they're calling your service. The other side of it is dependency contract changes. So maybe I don't want to use DynamoDB to store my stuff anymore. Maybe I want to use Postgre, or I want to use an RDS running Postgre in AWS. All of that is totally fine. You would maybe need to do a little bit of changing of your test setup and maybe some of that lifecycle management stuff I talked about. But your tests that you actually wrote to like do all of your requirement checking, those really shouldn't need to change that much. Just your test setup. All right, that was a lot of information to kind of throw at you, which is why we're going to do the entire process from start to finish together in Python in just a second. But before we dig into that and start, showing what an application would look like, any thoughts or questions on any of that stuff so far? No. All right, everyone's an expert. I love it. Okay, so let's take a look at our app requirements for our Python application we're going to write together. We are going to make a teammates API. So I've written a couple of these before. It's just storing different people that work here, maybe an employees API if you've done one of those. And it's going to have some very limited information about people in it. So we have an endpoint called /teammates, and it's going to support a get and a post method for HTTP. The post endpoint creates a new teammate object, stores it in AWS DynamoDB. Could store it somewhere else. It doesn't really matter. That's okay. The post endpoint supports a body with a first name, a last name, and an age. Some validation: the first name must not be empty, the last name must not be empty, and the age must be a number between 18 and 99. All right. At the end here, we have the get endpoint should return an object with a list of teammates containing all created teammates. Teammates will have the fields first name, last name, preferred name, that's new, and age. And then the list will return alphabetically by first name. That's not probably what we would do in a real API, but we're going to do it here. And then lastly, when creating a teammate, we want to consume an API at preferredname.com, everyone's favorite website. And that will give you any preferred names for the first name that was sent in, preserve that preferred name if it exists to the teammate object. Sound good? Awesome. Shouldn't be too bad. All right, let's see what the setup of our application looks like here. So we have a PyProject YAML, so I'm using Poetry to manage our dependencies in Python. If you guys haven't used that before, it's pretty easy. It has a little bit of metadata here, and then we just have our dependencies declared right here, as well as a few dev dependencies for testing and the like. Let's go through our dependencies. Python, obviously. Fast API is going to be our web framework that we're using. There's a lot of different options here. You can use Django, you can use Express, Express is Node. Flask, there we go. Lots of good options there. Fast API is my favorite. You also have Boto 3, which is our AWS SDK, as well as Boto 3 stubs, which is like a helper library to give us some good type completion in Python for interacting with those AWS services. And then we have python.env to just load some environment variables. Cool? All right, fairly straightforward, which is good. You'll be seeing me run make test a lot. We have a simple make file. It's going to do a Docker compose up and make those services that I talked about earlier available. I'll show you what the Docker compose looks like in a second too. And then we're just going to run with coverage PyTest. And then we're going to fail if it's under 100%. All right, let's look at that Docker compose file really fast. Very simple. We just have one local stack service. It's pulling the local stack image, and you see we're configured to use DynamoDB in our local stack service. You can set it up with a bunch of different ones. This one is fairly straightforward. And then we have a little bit of authentication information. So US East 1, it doesn't really matter. It's running on your computer. I am US East 1 now. And then we have a dummy access key and a dummy secret as our access key for that. And we're skipping SSL, and that's fine. And then we're making all of that available through port 4566. What is this fun commented out line, you ask? I'm glad you asked. We're not going to use it today. But as you start digging into using Docker containers to help support your testing, you're going to find that there's a lot of really cool options that a lot of them build in for you that do things kind of akin to lifecycle management. So local stack is pretty nice in that they have like 4 different directories that you can actually just mount information directly into, shell scripts, and it will run those shell scripts for you at different points in the container lifecycle. So I'm not going to manage it this way for this project, but I end up usually managing our stuff here by creating an init script and then just running a bunch of AWS CLI commands against local stack when it starts up, and this handles running it all for me. But this is not the only Docker container like that. There's a whole bunch of them that do stuff fairly similar to this. I think even like if you were to run a Postgre database container, there's like a lifecycle thing too there where you can stick scripts in a certain place and it'll run those scripts on startup for you, which is really cool. So any questions on any of our Docker Compose setup here? No. All right. You guys are full of questions today. All right, let's take a look at our environment file. So you remember how I said I am US East 1? Well, we need to actually have our app know that I'm US East 1. So AWS and Azure actually both make some nice environment variables available that make it where their SDKs will, unless you configure them incorrectly, but if you're using as vanilla of a configuration as you can when you're using their SDKs, you can have them consume these environment variables and know that they need to point to this fake local version of AWS or this fake local version of Azure instead. So that's what we're doing here. So as soon as our app starts up, it's going to call python.env. It's going to load this environment file. And then any AWS SDK resources we make are actually going to be pointed to our local host 4566, which is actually local stack. All right. Then last but not least, conftest.py. So this is Pyowa, so you guys actually might have more familiarity than some other people do on testing in Python. Testing in Python is fun because they have fixtures, all right? So who's familiar with fixtures? All right, quite a few hands. I'll spend a couple of seconds here just because they were new to me when I started Python. They kind of serve 2 different purposes in my eyes in Python. One is if you wanted to run certain things during your testing lifecycle. So if you've worked in other testing libraries before, you'll often have like a before each or something like that. And you might need to annotate it with something, or you might need to name it a certain thing. And it'll run before every single test, or it'll run before every single class, or it'll run before every single session, or something along those lines. PyText fixtures can do that for you. So you can see here that we have this that says PyTest fixture, scope session. You have a couple other ones. Well, we're not super complicated here, but you can also say scope function and scope maybe class or module. I can't remember. I don't use that one very much. But that will handle doing that for you. So if you have a before each that needs to run, throw a PyTest fixture on it, set it to auto use true, and it will automatically use that and run it before every test or every session for you. Thing 2 that it does is kind of like dependency injection, if you've ever used a dependency injection library before. So here's actually a really great example of this. So we are running this PyTest fixture, and we're creating what's called client, and we are making a test client. So this is something that's made available to us by Fast API, and it really doesn't matter what web library or web framework you're using or in what language. Pretty much all of them have some version of this. It's just like a pre-configured thing that's pointing to your app. So we could not use this at all and just use straight like requests library to make calls to our app in our testing if we wanted to. But this and many other web services or web libraries make it very, very easy to just new up an object and it's already pointed at your application, and you just need to give it the last path portion. You'll see what that looks like in a second. But the way that this works like dependency injection is we are making this test client at the beginning of our session, and then if we just put the word client in our test parameters at all, it's actually going to take this test client object and inject it into our test for us so we can use it. All right? So you can see that we have a couple of examples of that. This one down here is really doing more of that DynamoDB state management that I talked about before. So this is one of those necessary evils of using a Docker container with its own state in your tests. So you can see that we make a quick Dynamo client using Boto 3. We have a table name of teammates, and then we just try and delete the table, and then we recreate the table. Like I said before, a lot of the times when I'm doing something like this, I will create my table in that initialization script that I put in the Docker mount instead. But because we're kind of doing everything more in code here, you can just delete the table and recreate it. Often I would create it in the init script, and then this would instead just go scan the whole table and delete everything inside. Either way is fine. Do it whichever way works best for you. And then at the end, we're yielding DynamoDB, so we could take this and stick it in our test as well. And then down here are some default API behaviors. So do you remember how I said we're going to call preferredname.com later? Well, preferredname.com doesn't really exist, but in our tests it does. So instead of us mocking and saying don't actually make this HTTP call, we are instead going to set something up outside of that. And pretty much every language and framework has a version of this as well. I've done it in Kotlin and Java and Node and Dino and all sorts of stuff. So it's there. You just need to find it. But this one is called request.mock or request_mock. So it's actually making the HTTP call out, and then it's basically intercepting it and returning an HTTP payload. So you're executing all of your actual web layer code or web consuming code, and then it's taking in the JSON payload or the whatever it is, the status code that it gets back, and handling like it would an actual HTTP call. So here, request mock in Python, very simple. We just set it up and we say .get. And so if the request matches preferredname.com, it's going to return name none. And then if we get more specific and say if I send in a query parameter of Benjamin, it'll return back name Ben. And if I send in one of Jacob, it'll return Jake. Some pretty common preferred names there. So this is our entire setup. We're basically just saying, I have a fake version of DynamoDB that I'm managing some state for, and I have a fake web API that has some predetermined behavior that I can leverage during my tests. Any questions on any of that? Yes. That is imported from the request mock library. Yep. So if you go to the request mock documentation, it's actually pretty good. I was looking at it earlier today for something. But yeah, a lot of testing libraries in Python have about 17 different ways you can use them if you want to. However, the way I've moved towards using most of them is through fixtures, because most of them make a version or a fixture of their thing available. So in this case, this request mocker is actually a fixture that request mock is making behind the scenes for me that I'm then injecting into my other fixture and building on top of. All right. So in the past, you would have to like make a new version of the request mocker and like do some stuff with it, or you'd have to throw an annotation on all your tests. But now you can do pretty much everything through fixtures. All right. Any other questions? That's great. Okay. So we know what environment we're in now. Let's go look at our actual application code. Teammates.py. All right. This is pretty advanced Python, you might say. First off, we're going to load our environment variables like I talked about before. Their only purpose is to make sure we're pointing at local stack right now. We are going to make a new fast API app. And that's really all you have to do to like stand up your web server in fast API. Very, very simple. And then down here, we have two endpoints, one get/teammates and one post/teammates, called get teammates and create teammate. Doesn't really matter what it's called. And then they both return hello world. So fairly straightforward. Let's go look at our tests. So I've pre-created a lot of tests. What I'm going to do is not spoil the ending. I'm just going to comment all of these out for right now so we can focus on each one at a time. So let's take a look at our first ones. This is going to be how we're going to write all of our tests. Like I said, I'm going to use this kind of given, when, then framework here just to organize my thoughts. And I also think it really helps when you're writing new tests to just write the name of a test, write all of your given, when, then comments, and then say pass at the end. In fact, that's what all of these other ones are. If you want to look at it, given, when, thens, we're going to implement them all together, but they just pass automatically. So we were saying when delete teammates is called, great, we call delete teammates, then the status code should be 405. It should return method not allowed, which is status code 405. Then we have the exact same thing here. So we are really going back to our we have a teammates endpoint that supports get and post only. Great. We're checking that some other common methods don't allow to be called. So let's go ahead and run our test together. So I'm just going to pop this up. Let's clear and say make test. So this is going to do our Docker Compose up for us. And you can see that's really fast. That did everything for us. It'll take a little longer the first time you run because you'll need to pull the image down if you don't already have it. But you can see we ran 2 tests. Both of them passed, and we have 80% coverage in our app already. Look at us go. Our app is 1 file, and it's very small, but that's okay. Let's close this guy. So they're both already passing just by the nature of us setting up Fast API and setting up our 2 endpoints, right? Things are going to get slightly more complicated from here, but not that much. Let's look at our first test together. So this one is going to be tests that get teammates, or test get teammates when no teammates exist. I like to throw one of these up just so I can get my get endpoint working in a CRUD app. And then even if I have no data, it doesn't explode, right? That's always nice. So given no teammates exist, great, I don't need to do anything for that. No teammates exist by default, right? When get teammates is called. Okay, cool. So let's call get teammates. And all we have is this test client that we're kind of injecting that I talked about before, our fixture that's already pointed at our application. We're just going to say client.getTeammates. Then we're going to check that the call is successful. All right, so assert in Python that resp.statuscode equals 200. I could say like resp.ok or something like that if I wanted to. Depends on what language and what kind of syntactic sugar it has for you. But this is a really simple way to do that. And then we're going to check that the call returns an object with an empty teammates array. Okay, cool. Let's do that. So assert that resp.json is how we get our response equals a dictionary with teammates. And it's just an empty array like that. And we know how to program, so we're going to put a double equals there instead. All right, everyone follow setting up that test? Looking pretty good? Pretty simple, straightforward test, right? Excellent. Let's break it. All right, we see so much red. That's perfect. So if we look here, we can see that it says, hey, no module named teammates. Oh, no module. That's a different than what I was thinking. Oh, I don't know why it said import teammates here. We don't need to do that. Don't do that. Thank you, VS Code. Yeah. Hey, all right. That's a more manageable amount of red. Good. So we see that we still passed those old 2 tests, which is perfect. We didn't regress. And then we have our new one failing, and it's saying it asserted that hello world equals our empty teammates array. And that's because we're returning hello world in our API, right? Cool. If you guys have ever done any test-driven development stuff, this should seem pretty straightforward at this point and pretty familiar. So let's go implement. Back to teammates. .py over here, and let's be a little bit maliciously compliant, shall we? So let's just go here and return teammates and return an empty array. This is going to pass our test. That's fine. Let's push it. Cool. All our tests pass. We're ready for prod. All right, let's go and continue to work on the rest of the requirements. If this happens to pass all of our tests that map to all of our requirements, technically it's good to go. However, it doesn't match all of our requirements yet because we haven't finished implementing all of them in the testing side. So we're going to find a time later on when this is going to start failing for us. Not this test necessarily, but new logic that we need to be implemented. So next up in our tests, we had testing out our post stuff. So we're going to do test creating our teammate. So when the post teammates API is called with a valid payload, then the request should be successful and the response should be empty because we don't return. Sometimes like creating a new object will return the object for you. We're not going to do that. So let's write some tests that check that for us, shall we? So when we call our app, and we're going to call post for this, right, instead of get. And we're going to pass it a payload. And I don't remember how this works off the top of my head. JSON, I believe that's how we do that. And then this is going to take a few different things. I believe, let's just write something for me. I think we had a first name that we were going to send in, right? And that can be Grey That's my name in case you don't remember. We have a last name. We're going to make that Lovelace. And then we are going to have an age, which is regrettably 35. All right, so that is going to be our hopefully valid payload that we send into our API. We want that request to be successful, so we're going to do just what we did before, pretty easy. Assert that our response status code is 201. If we were being fancy, we would return 20 something for created, 203 maybe. I can't remember what it is, but in this case, we're just going to do 200. And then the response should be empty. So we are going to assert that resp.json equals none. All right, let's run it. Now, just kind of think through, we failed. My question for you is on this test, do we need to create the teammate? No, it's a trick question. We're calling create teammate. Our test says create teammate. We're not actually checking that the teammate is created with this test. We are checking that we can call in with a valid payload. It works. It returns a good status code, and that we get no response back. So that's what we're going to implement. Okay? You can see here, it failed just on the fact that I returned hello world when it was expecting none as the returning body. So let's go do that. And again, it's going to be pretty easy. We're just going to say pass. All right, we're done. Okay, cool. We're passing. Good to go. All right, now we're going to start paying for our past sends a little bit and actually have to implement some real logic. Go to test teammates and let's look at our next one. Oh, actually, no, I lied. We're one step away from that. So who's ever used a parameterized test before in Python? Okay, cool. Parameterized tests are awesome. They cut down a lot on a lot of this boilerplate that you're going to run into. So we have a whole suite of validation requirements, right? First name must not be empty. Oh no. First name must not be empty, last name must not be empty, and age must be a number between 18 and 99. Now, I'm sure if you've worked in multiple applications before, all of this validation logic could be done 1,700 different ways. And you could implement it in a lot of different places, and you can share it. You can do whatever you want to. In our case, we're going to be doing it all through Pydantic, but it doesn't matter. We're just going to send it in and expect it to explode. So here, we are basically going to say when a post teammates API is called with an invalid value, then the request should return unprocessable entity, which is a 422 response code. We could get fancy and we could check for like very specific language in the error if we wanted to, but we're not going to because this is an hour long. So the first thing that we do is we are going to inject what our invalid value is going to be into our test. And we're going to write quite a few of these. So in this case, we're just going to check that if I send in what is normally a valid payload, but I add first name of none, then it's going to tell me it's an unprocessable entity, right? So let's give that a try. All I do is I come down here and you can see that this is Python being very Python for you. We just say field comma value and it expects these guys to match up to field and value in our tuple. And then we inject field and value here as our values. It's a little bit weird because you have to like match this string with this argument name, but that is the way it works. So we're going to come here and I'm going to help us out a little bit. So we're going to have to call with what is otherwise a valid payload, right? And we already know that this payload over here is valid because our test passed. So let's just take this guy out and let's create a little helper that says valid create teammate payload equals, we'll throw that guy there. And then just replace it in this test, which should be identical. And then come down here, and we are going to call post again, and then give it kind of a hybrid object. So we're going to destructure our valid create teammate payload, which is going to say dump all of the keys and values that existed in this guy into this new one that I'm making. And then we're going to overwrite stuff with our field and value we have here. So if I put field and I put value, like that. If I remember my syntax correctly, that should work and it should override that value for us. We're going to see in just a second, right? So we call And then when we get that response, we should be able to check assert response.status code equals 422. Cool. Everyone with me? Feeling good on that? Excellent. Let's run it. Okay, we failed. Great. So we called in. It gave us a 200 back when we expected a 422. Let's go implement. So in Teammates, the way in Fast API that you can get post bodies to be in your services is you create a Pydantic model that does that. So we're going to say class, and we're going to say create teammate with 2 M's, request. Okay. And then if we come up here and we just say base model, this is how you make something a Pydantic object. You import base model from Pydantic, as you see up there, and then you inherit from base model in your class that you're making. They actually set it up to be pretty slick. Then we are going to start making our different fields that we care about. So we care about first underscore name, and that is a string, right? Good. So do you notice that I put string and I didn't put optional string, or I didn't put string or none? In Pydantic, that means this is a required value. So if it wasn't required, I would have to give it a default value, and I would have to say that it's okay that it's none, or I'd have to mark it as optional in some way. So this should actually pass our test for us. There's what? I spelled name wrong. I wouldn't do that. I don't know what you're talking about. First named. Thanks. Okay, so we are still failing. Good to know. This is a problem of how we configured our library. So I made that really cool Pydantic object. What did I do with it? Nothing is correct. I even put a good first name that's not misspelled. So we need to take this create teammate request and put it down here. And we are going to say request of type, well, not quest, request of create teammate request. Great. Now let's run it, and it should hopefully actually pass this time. Perfect. Okay. This, I want to take a second to stand on my soapbox. So this is one of the reasons I like this type of setup. So you probably would have been able to catch something like this with your normal test, because you would probably be calling create teammate directly, and you would be passing in a request object if you were writing tests in the way a lot of people are used to writing tests. However, there are a lot of cases where, like, let's say that not that I've ever misspelled something before or added an extra D, did that. Do any of your tests catch that? And the answer is no, right? We have a requirement to make a teammates API available at a particular endpoint, but we have no tests around are we actually making that endpoint available. And that is something that this can catch. And there are about 17 different ways that you can configure these different libraries to make things available the right way. A lot of people are like, hey, I don't like this approach because I'm testing the library, and the library is already tested. I shouldn't be testing it. And I agree. But you have to interact with that library, and you have to configure that library appropriately, and you have to pass that library different requests and get its responses back and do the correct things with them. And you need to test that those things are working appropriately. And this is a great way to do that. We will also see this happen when I start consuming the DynamoDB object in just a little bit. But that is something that could easily have passed by tests the way people write tests a lot of the time right now. Cool. So we have that guy running. Let's go back to our test, and let's start adding all of these parameterized tests here. So we had a requirement, not only that it can't be none, but it can't be empty, right? So empty would mean a blank string is not okay. Well, I happen to know that in Pydantic, I can do some cool stuff around that. So let's send in a first name that's a blank string. And if I run right now, it'll fail because it'll pass. It'll fail because we don't explode. So you can see that we get a 200 when we're expecting a 422. If I go back to teammates.py and we look at this guy, there is some fun Pydantic magic we can do, and you can do this in Spring Boot with a validation library, the Jakarta library, and some other stuff. We can just say field from Pydantic, and then we can just give it some fun things like min length. So I'm just going to say that this string has to be at least 1 character long. That way it can't be blank. And then if I run my tests, hey, we're passing again, right? What's up?
Does your shell prompt have a table flipping emoji when you have a non-zero exit code?
I'm glad you asked. The answer is yes. Yeah, thank you. Yeah, if I ever exit incorrectly, I flip a table, or my console does. I'm calm. So that's how we can implement something really easily like that. Let's go do this for last name as well, because we have the exact same requirements around last name, right? So again, let's go to our tests. Let's fail our tests because we like to see red. We will change that to last name. We will run. We should see 2 failures, right? Which we do. And then we can come back here to teammates, copy this guy, and just call it last name with no D. And it should work again. Beautiful. Now, let's go do the age requirements. So what were our requirements again? It's always good to go back to your requirements and actually look at them. Age must be a number between 18 and 99. Great. So let's go do that fun thing where we start passing in a whole bunch of values that are invalid. So we have age, and I'm just going to do all of these at the same time. So can age be negative? No. Great. Let's have a test for that. Can age be 0? No. Let's have a test for that. Can age be 17? No. Let's have a test for that. Let's test our boundaries, right? And then 100. And I could do like a whole bunch if I wanted to. We're just going to focus on those 4 right now. Negatives are bad. We could throw lizard in there, like that one QA testing joke that people always like. But we're just going to do these 4. So if we run, we should see 4 failures because we don't explode. And let's go explode. So again, we are going to do this Pydantic style. We'll go in here, create an age. Age is a number, or an int in this case, right? So that'll take care of decimals if we wanted to add decimals to our test cases too. And then we need to do a field of some kind. So we're going to do field again, and we're going to give it a few more rules. So in this case, we said that we wanted it to be greater than, what, 18? And then we wanted it to be less than 100. 18 to 99. But I wanted my tests to fail. But I think he caught my error first. And he did. So, yep, that works great. I was going to be a jerk and put it as 100. And then we would see, because we're testing our boundaries appropriately, that it fails on one of them, and we would understand that we used greater or less than or equal to instead of less than. Cool. Again, all of this stuff, testing by calling the actual web layers, so we know it's actually doing this validation. I have run into problems with this before, like I've used Spring Boot before, and it has a lot of validation stuff built in, which is great. You can figure it all, but if you don't add the @validated annotation at the top, it does nothing. Or it does in some cases, like when you make the object inside your code, when you're trying to call a method with it, which is what our tests normally do, but when I call it with the HTTP layer, it just doesn't validate. This would catch something like that, which is really, really nice. Okay, so that's all of our validation logic that we had there. Let's see, yep, we have finished all of these requirements so far. Let's take a quick moment. Any questions or thoughts on any of that stuff so far? You guys feel free to kind of hop in whenever you want. No? All right. Is any of this new or helpful stuff? Let's check that we're on the right track. Yeah? All right. I see a couple thumbs up. I'll take it. Let's take a look at this new one. So the get endpoint returns an object with a list of teammates containing all created teammates. We have that one empty one that we've already tested. And then the teammates will have the fields first name, last name, preferred name, and age. And they will return alphabetically by first name. So now we're actually going to have to start implementing some logic. Yay. So let's go back to our tests and let's see what our next tests look like. Test get teammates. So let's say given 2 teammates exist, when get teammates is called, then the call returns an object with the teammates array containing both created teammates, and the teammates should have the appropriate values and be sorted by first name. Seems pretty straightforward to me. Let's go implement it. So given 2 teammates exist. So we're just going to call our post again. And this is where some people can disagree on how you should do things, and that's totally fine. Sometimes, depending on your implementation, people will go in and they'll be like, hey, let's say we're storing these in DynamoDB, which we're going to do. And they would be like, hey, if I have a given two teammates exist, that means I'm going to go inject two things into my DynamoDB. And then when my get test runs, I should be able to see those things that I put in there. I want to be as decoupled from that as possible. And typically the mindset I try and give myself is if I deployed my application out and then I had someone that was supposed to test it, I would be like, hey, it's deployed. Here's the endpoint. Go test them. Things work the way you expect it to. And their test for this would be, all right, I'm going to call post to create a teammate. I'm going to call post to create a teammate with a different name. And then I'm going to call get, and I'm going to expect that those teammates come back in the correct order and have all the information they should have available. That's the way that we're going to test it as well. Okay? One is not necessarily worse or better than the other, but I like the fact that it's decoupled from the back end as much as possible. So we are going to create teammates, and I'm just going to grab our payload that we have up above. We could reuse this valid teammate payload if we wanted to, but I'm just going to put it directly in there so we can see everything. And then let's make another one here. And we don't even need to get this response back. We can just make sure it calls in and we're good. And we can even throw a fun thing called raise for status. That means if it comes back with a bad status, it actually throws an error for us. Thank you, Python. And we're going to have Gray. And then what is a name that is not Gray, that is after G alphabetically? Anybody? Whitney. All right. Sorry, Whitney is over there. Whitney is my wife. Say hello, Whitney. And so her last name is also Lovelace, and she is 29, let's say. All right. So eternally, it's going to be checked into GitHub, so it'll be law. Yes. So we're going to create Whitney as a teammate. We're going to create Gray as a teammate. Now, if I called this normally and then I called and got stuff back, I would usually expect it to give me back the objects in order of creation, right? So that's why I'm specifically putting Whitney first to make sure that when I'm testing this, it's actually changing the sorting in some way. I'm not even going to implement that at first. We're going to see it fail. But just so you know why I'm doing it in that particular order. Now we're going to call get teammates just like we did before. That's another nice thing. You can just copy a bunch of this stuff, or you can make helpers, test helpers a lot of the time, streamlines a lot of these things. The call returns an object with a teammates array containing both created teammates. Great, let's go up and grab our stuff that was checking for teammates before. Actually, no, we're not going to do that. That's fine. We're going to say teammates equals resp.json. And then this has that teammates array inside of it, so we're just going to grab it. So now this should be the raw objects, and then I should be able to assert some things, right? So we're going to assert that teammate 0, teammate 0, thank you. I think I heard someone say that. Name equals, and then we said that Gray was going to come back first, right? It's going to be Gray. And then we're going to do some other fun stuff. So let's say, oh no, not name, first name. I apologize. We're going to do last name equals Lovelace. We're going to do age equals 35. I know this can seem verbose. I would probably actually use like a faker library or something like that to generate random values for a lot of these normally. But just because this is a demo, it's a little easier to see these raw values. And then we are going to have preferred name as well, right? Is that how you spell that? Let's go back to our requirements. Hey, there we go. And this should be none, right? Cool. So we should see that. And then if we take all of these, pop them down here, we'll change this to a 1. Could I set these as a variable? Yes. Am I going to? No. We'll say Whitney, Whitney, and then we will grab her age as well. And I know I threw that C in there accidentally. And then her preferred name is also none, right? Cool. That's our test. Pretty simple. Now, while I run this and it explodes, any thoughts on any of that? Feeling pretty good? We're going to have to do a lot of implementing here. Like I said, we did a lot of maliciously compliant implementing earlier that we're going to need to pay for. So we are testing with list index out of range, and that's because it calls in, creates those things. And then when we get our teammates array back, we are saying it's 0. In fact, this is a slightly misleading error message It's also good to think about what might happen in certain situations and what your error messages might look like for your tests. So I would probably go back in here and double check that assert length of teammates equals 2. That way I know when I run this again and it fails, we should be able to see that it just says teammates is 0 when I'm expecting it to be 2, which you see right here, right? Much more straightforward. You know what's going on a little bit more. So let's go implement the actual Dynamo logic, shall we? Who's used DynamoDB before? Yeah? Okay. It's a little weird, but it's okay. They have some abstractions that make it a little bit easier to work with, and so we're going to use some of those. So up here, we're just going to create things. Like I said, this would normally be in some kind of broker layer or a service layer that has more app logic, or even like a DynamoDB specific service that has an interface that it adheres to. But we are just going to throw it right here. So DynamoDB equals boto3 dot resource dot client. I'm trying to remember how this works. And we are going to say Dynamo, I think it's DB. And we're going to import boto3. Cool. All right. It all lit up. That means it's right, right? From DynamoDB resource, we are now going to, well, actually, we can double check. What does this say? Okay, cool. DynamoDB service resource. That's that boto3 stubs that I've imported that actually helps a lot with these types. So here we are going to make our table resource. So in our case, we had a teammates table, right? So we're going to say teammates table equals DynamoDB dot table. And then we are going to pass it the table name. And that creates a, yeah, is that the right one? Name string. Okay, cool. And then this should be teammates, just like we made it back in our conf test, right? This right here. Okay, that would probably usually be injected as like an environment variable of some kind. So we're going to make our teammates table, and let's hover over and see what the, okay, so it's an underscore table. I think that's correct. We're going to find out in a second. It's another nice thing about doing this is I don't have to mock something I don't know how it works. It's just going to actually call the real thing. And we're going to come down here to create teammate, and we're going to say teammates table dot put item. We're going to put a new item in there, right? And so I think it wants item equals, and it's going to take this guy. So let's do what I would probably naively do here. We're sending in a teammate payload. We want to create a teammate payload and throw it in Dynamo. Great, let's just throw that request object right up in there. Often it will need to be serialized into a dictionary or a JSON object of some kind. In most Python things, you would do underscore underscore dict. Because we were using Pydantic, you instead use model dump. Okay, so I'm going to try it like that. Let's see what happens, shall we? And we failed. All right, and we failed because when we said calling the put operation on one of the, okay, we can go up here. There we go. Validation exception. Calling put item operation, one of the required keys was not given a value. Okay. This is something that would definitely not be caught if you were mocking out DynamoDB, right? DynamoDB expects that if you set up a table and you give it a primary key of ID, that ID is going to be present when you try and save it, right? But if we were just saying, don't call this, I'm going to have it send something in and I'm going to like mock that it would return this object if I were to ask it for it, we would never have any idea that when we push this up, it's going to explode. So let's fix it. So we are going to do something similar to what we did before. We're going to make a new object. We're going to deserialize this guy and throw all the good bits in there, and then we're going to add in the pieces that we need. So we are going to add an ID like we talked about before. In case you guys aren't aware what it was complaining about, if I go back to conf test and look at our table setup, when we created our DynamoDB table, we gave it an attribute lowercase ID that is the primary key of it, the hash ID, if you will. So it expects that to exist. So we're going to give it that, and then we're going to give it some kind of UUID thing. So I'm going to come up here, import UUID, come down here, UUID.UUID4, And then this wants a string, so we're going to stringify it. All right, good? Making sense? Cool. So on our test again. Is it going to work? No. But is it going to break for a different error? Yes. Different error is always a good error. So assert 0 equals 2, we're back to our original error, which means when we call into our create teammate with that payload now, it's not exploding, which means that we are probably persisting to our DynamoDB correctly, right? So let's go double check that. Our problem is now that if we are creating things correctly, we are not fetching them correctly. We have a hard-coded blank teammates array. So let's go grab stuff. We're going to take the same teammates table. I think I'm just going to call for brevity .scan right now. Scan is just going to give you like everything on the table up to a certain amount. Don't do this in real life, please. And then I believe, yeah, items is the value that comes off of it. So we're going to say items equals, or here, let's be good. Teammates equals, and then we're going to come down here and throw our teammates array inside teammates. Cool? Great. All right, we failed again, but new error is a good error. Come up here, you can see that we got past the part where we asserted our length of teammates was 2. So we are persisting things, we are fetching them correctly, which is good. Then we come down here, we asserted that the first name was Gray, and unfortunately the first name is Whitney. All right, so it is returning to us in the order they were saved, which is kind of what we expected out of the box. So we aren't matching our requirement of they need to be sorted in a particular order. Let's go implement that. So in teammates.py, we get our teammates back. Because this is Python, we are not going to do this immutably. We are just going to call .sort. I'm going to remember how this works off the top of my head, and it's going to be a little bit. So I think we pass it key equals. All right. We're sorting by first name, so we need to make a lambda. So lambda teammate. Okay. So for every teammate, we're going to grab teammate and say first name. And it has no idea what a teammate is, so we are going to wrap that in a string. Cool. I could probably type this guy instead, but I don't know how to do that with a lambda off the top of my head, so I'm not going to. Okay, cool. New error, right? So we got past the part where we were looking for Gray, so it's giving it to us in the right order now. Lovelace, 35, none, all great, except for when we tried to get preferred name didn't even exist. Not that it's none, it just has no definition at all on this type of object, which if you try and access it in this dictionary way is going to explode. We want our payload to return with preferred name equals null, not just no preferred name at all in the payload. So this is a great test to make sure that's actually happening. Let's go back to our code and fix it. So down here, when we added our ID, we are just going to add preferred name. Again, probably misspelled. Thank you. And then we are just going to make it none because we are in Python and they use none. And if we come back here, this should equate to null on our side and our test should pass, which it does. Cool. We did all the hard implementing parts. That was the difficult portion. So yeah, the really nice thing is this runs. I can tell you from experience, having written a bunch of tests that integrate with cloud native services like DynamoDB, RDS, all those kinds of things, that I can write a bunch of code, I can write some tests around the business logic of that code, and then when I hit the deploy button, I pray. Now I don't have to. Praying is probably good, but when I deploy, I know that it's actually going to the DynamoDB spec now, and I don't have to worry about the fact that I've been making a lot of assumptions in my code and in my testing layer. Sound good? Cool. All right. I think we have one more requirement left. Let's go take a look at it. Last one. When creating a teammate, consume an API at preferredname.com, and it will give you any preferred names for the first name sent in. Preserve the preferred name if it exists. All right. Let's go look at our conf test and remind ourselves what our kind of default behavior for this app is out of the box. Conf test. Cool. So default API behaviors, we have, by default, it's giving us none. And then we have Benjamin and Jacob down here, turning into Ben and Jake. So if I write a test, I should be able to say something like, nope, that's not how that works. All right. Oh no. There we go. Given a name that will be returned, that will return a preferred name from the preferred names API. So in that case, this is Benjamin or Jacob, right? When post teammates is called with that name, when get teammates is called, no. Oh yeah, post teammates is called with that name, so we're going to create it. Then when we get the teammates for it, then the call returns an object with the newly created teammate with the given name and the preferred name. All right. So again, exactly like if I deployed this, gave it to somebody, and I'm like, hey, test it out. They would create Ben, and then they would call and see if it, or sorry, they would create Benjamin. They would call and they would see if it gave back Ben as the preferred name on the get endpoint, right? So we're going to do the exact same thing. Let's come up here. We'll do client.post. We are going to say Benjamin. Yeah, M-I-N? Yeah, that's right. Sure. This will be Benjamin Doe. He's also going to be 35. Why not? We're going to call post with that teammate. Oh, so there we go. Those can kind of be combined. When get teammates is called, so we're going to go grab our teammates again, similar to what we have here. Oh, no, similar to what we have here. Then the call returns an object with the newly created teammate with a given name and preferred name. So I'm just going to go grab that teammate out of here. So teammate equals resp.json teammates, and then 0. If we wanted to, we could even be nicer to ourselves and say assert length of this guy equals 1. Oh, with an R at the front. So we have our teammate now, and then we are going to assert that teammate dot or teammate first name is still equal to Benjamin, right? We don't want that to change. And then we are going to say that his preferred name, which I'm just going to shortcut and copy this time, is going to be Ben, right? Cool. Also, I forgot earlier, we did say that these teammates should have IDs when they're put in, right? We know that's happening because of DynamoDB, but are we returning it? I don't know. Let's actually add that to our test. So we're going to say that ID, and we don't know what the ID is going to be up front. We could like mock that out if we really wanted to and say when the UUID library is called, do this, and then check that it matches that. I don't care that much. So we're just going to assert that it is not none. And that's going to get me 99% of what I care about, right? We're going to do the same thing here and change this to teammate 1. Cool. And then down here, we're only asserting on the things we care about. For this particular test, if our logic changes that doesn't persist age anymore, I don't care if this one fails. I care if this one fails because that's the one that's actually testing that requirement. Cool. Run our tests, and we should see that it does not work. And that's great. So it said persist preferred name, assert that none equals Ben. Our preferred name is none. Let's go implement, and that'll be our last implementation we have to do. And then we can push to prod, and we're done, right? So teammate table, put item. We are going to make a quick little definition here. And again, this is something that would probably be in another layer. I would probably make a preferred names broker that would handle all of the interactions we have with the preferred names API or app or whatever. And the nice thing is I could do that and I don't have to change my tests at all, right? Whereas in a lot of cases, you would have to make an entire new test class just for that and then rip out a bunch of stuff from over here and have a bunch of mocks over here. It's gross. So we're going to say get preferred name. I can tell from the laughs I did it wrong again. And we're just going to accept that. That's fine. This is the world we live in. This is why I need tests. So we're going to have get preferred name. This is going to be a method, and that method is going to have a contract of some kind. So I'm just going to say that if I give it a first name, that's a string, I want it to give me back what that should be. So here we are going to call out using the requests library. So requests, do we have that imported? We do now. So requests.get, and we are going to call our URL. Again, this is something you would probably want to add into a environment variable and consume there instead. But we're going to call this directly, and then we are going to add on our first name. I think there are ways that you can add these in as like an actual like key map of some kind. I don't remember what that is off the top of my head. But we're just going to say that, and then what was our thing here? Name equals. So we're going to say name equals, and then we're going to pass it our first name that was passed in. This is not the cleanest way to do this. I would probably refactor this to pass in the arguments as an actual like map of some kind or a dictionary of some kind. But we're going to do that and see what happens. So resp equals that. We are going to, for right now, the easiest way for us to do this is just say to raise on error or raise for status. Does this return anything? That's cool, docs. I didn't need to know. Someone know?
Don't think it does.
Don't think it does? No, that's a none. Okay, cool. So we'll just say resp, and then we'll say resp dot raise for status. And then down here, we will return resp dot JSON. And then if we go look at what this looks like, we always return a name inside, right? So we are going to say this and then name. Now, what happens if the name doesn't have a preferred name, right? That can vary depending on what types of APIs you're calling. Sometimes it would return 404, sometimes it would return none, which you would need to make sure that you're implementing correctly. In our case, we looked at the documentation beforehand because we're good people, and we made this is effectively what I would call a stub in this case. We made our stub behave like they would, which is if I call and there isn't a one that's found, they still return our object. It still contains name as a field. It just happens to be a null value, right? So we can write based on that. So if I do this, and then I come down here, and instead of preferred name none, I just say get preferred name and pass in request dot first name. And if we turn completely green, we're done. And we do. Excellent. The other really nice thing about this, not only did we check that all of our requirements are met, we also have our coverage, and our coverage is at 100%. Now, I know when I say test-driven development or I say tests, that gives people a lot of like baggage that comes with it. If I ever say requiring 100% test coverage, that is like 10 times the baggage for a lot of people. I can say developing this way and writing my tests like this, even though it does have downsides like having to do that state management and everything, and it also is like a little bit higher cognitive complexity going into a new project, which can be a good thing sometimes, that you have to like understand the app better to write the tests. I've seen people like write tests for a very specific portion and it works great there and it does not work at all in the actual application. But it does take a little bit longer for people to get spinning on these types of things. But the other really cool thing is that you get coverage. So I pretty much on all of my apps now require 100% coverage because you get so much of it out of the box just by writing like 2 or 3 tests here. And you are covered both from an implementation standpoint by understanding your coverage, and you are covered from a requirement standpoint by implementing all of your tests that way. The other kind of cool thing about it is if you ever write code that doesn't directly help with a requirement, why are you writing the code? You know, if you're making a library of some kind, that's fine. You're still writing tests from a consumer standpoint of that library. But if you're making a web app or you're making something like that, that's there to solve like a particular business problem, you shouldn't really be writing code that's not solving some kind of business requirement. You're probably introducing complexity that you don't need to introduce for the current business requirements that you have. Make sense? All right. That was me talking for a really long time. I'm sorry. Let's open it up. It looks like it's about 6:50 right now. Any questions, thoughts, follow-ups? Do you guys hate this? Do you love it? Is it your mortal enemy? Yes.
The question in the order in which you do things. So
Mhm.
the 1 thing that trips people up is you're supposed to like write all your tests ahead of time,
Mhm.
your requirements. I notice you're like each feature, then a test for it. Typically, what you do.
Even in test-driven development, a lot of the times that will be what I do. So you're just taking each requirement one at a time, right? There's a minimum viable product of things that you can actually deploy out and start marketing or start using. And that's usually the point where it's like, hey, I have to be able to match all of these requirements before it's deployed out. But in terms of writing those tests, I will take very small features, write a very small test for it, very small feature, write very small test. Yeah. If you've ever heard of extreme programming or XP, a lot of the time it's done that way as well. But I'm sure that there are people that will say, write all of your tests first and don't implement anything first too. It depends on what you want to do. What works best for you? Yeah. Derek.
With the test where you want to check the order
Mhm.
the database returns in.
Yep.
I've used Postgres, where if you don't actually decide what order or give it a sort by, it'll kind of just
Do whatever.
randomly.
Yep.
Is there a way like you can test for that? Because sometimes it might pass
Mm-hmm.
randomly.
So that is something I would typically do with a, like I said, with like a faking library of some kind. Here I hard-coded two names. I would usually programmatically generate two names. One is alphabetically in front of the other one, or I would even just kind of use volume and do 3 or 4 of them. 2 coming back in the right order by happenstance, it might happen. 4 or 5 coming back in the right order by accident is going to be much, much less likely, right? And if you're generating these names randomly, then you're not running into some other weird thing. You might not catch it on the first test pass, but you will catch it in like 3 or 4 test cases, or like running your tests. Yeah.
I was curious if you played around with hypothesis for generating the test cases.
I have not heard of hypothesis. Can you tell us what it is?
It's something that I haven't tried yet, but it's supposed to be a mocking tool that generates your fake data, and I think it's meant to explore areas that you might not think to put into a test case.
Gotcha. No, that's cool. That sounds fun. I would definitely check it out. But no, I haven't used it. Yeah, in Python, I've used Faker before. In JavaScript, I usually use chance.js, if you guys have used that. And then I think Java has one too that I cannot remember off the top of my head. Jack.
You kind of preface the whole talk with saying that this is like really helpful in a lot of like microservice-based. How do you end up like doing these kind of like wrapping around every service when you're working with like multiple repositories and that kind of stuff?
So let me see if I understand the question. So you have a lot of different services, a lot of different microservices, right? I mean, typically to make sure that I'm getting all of the coverage that I want in those, I will just say for each one of them, I'm implementing a 100% coverage. And then each of them have their own life cycle. I would actually say, in my experience, that setup is a little bit easier to work with to make sure that you have all of this set up than in a mono repo of some kind or like a larger monolith. Because then you have all of these different pieces that can kind of get checked in and go in unnoticed a lot of the time. I'm not a big mono repo fan, but I work in them a lot, and I've found that usually stuff slips past or is like done slightly differently in those more. And then when you do have a lot of different repositories, a lot of the time they're starting from a template or they're starting from something else that like you can have it where it's like, okay, you're spinning up a Python microservice, great. Copy this guy, fast API setup, you're good to go. And it already fails if you don't have 100% test coverage. If I understood your question correctly.
Yeah, so I guess like the behavioral driven development would just be wrapped around that entire singular service.
Yep.
Okay.
Yep. Yeah, and that is one thing I really like about microservices is when you start bundling a lot of code and it lives in the same place, people are much, much more likely, like developers are lazy. We all know this about ourselves, right? If we're going to be able to make a change in one commit, we're going to do it in one commit instead of 5 different commits if it's available to us. So often if you do have a lot of services in one repo or you have a monolith, they're going to be like, okay, so this thing, which has a completely different responsibility than this thing and a completely different responsibility than this thing, all need to be updated at the same time. So I'm just going to make changes to all of those and check it in. In reality, a lot of the times, those aren't actually deploying together or at the exact same time. So you're going to introduce downtime, and that's bad. when you are structuring things in separate repositories as different microservices, you often need to treat them as if their own application, and they are responsible for maintaining all of their consumer contracts as best as possible. So if you do need to add a new endpoint and you need something to start calling that endpoint, you add a new endpoint and keep all of the original consumers whole, even if it's just one app that's like way over here, right? You add a parallel endpoint, go over here, consume that new parallel endpoint, then come back and rip out the old stuff. I've found that pattern works a lot better and doesn't introduce any downtime, and it kind of keeps cross concerns minimal, which is nice. Yeah, Pat.
You mentioned local stack.
I did.
I've had some pushback against local stack.
Okay.
And the argument is that it's not AWS, it's not maintained by AWS, so we can't be sure that the implementation matches.
Okay.
In your experience, have you run into situations where the difference between local stack and AWS matters?
No. My main probably argument against that would be, is your code maintained by AWS? Because the answer is probably no. So anything that you're going to write as a mock is probably going to be much less compliant to what AWS actually does than local stack is, right? I don't know. I want to trust the experts in that space. I do, like, underneath everything, I do have that concern sometimes. Like, am I writing to a DynamoDB consumer contract that's not exactly the same as what it is in prod? And the answer is probably not. I've never run into that situation so far, but I can tell you that it's a lot more likely that this is going to match the contract than me writing a mock that doesn't have any contract at all. Yep. Yeah. Great questions. Any other thoughts, comments? Yeah.
So just trying to bring, let's say, something sponsored should write code. So trying to bring some reason to tell my client that this is giving some value. So writing like, okay, given this is an admin user, when something happens,
Yep.
So I have spent like X servers writing this test. And now it is like we need to spend only less servers on a manual test. Is that a right statement? This time it also, because we actually write the use cases. Every combination.
Yeah. So if I understand your question correctly, if you're spending all of this time doing testing kind of like this, or spending a lot of time creating a really great automated testing library, do you find that your manual testing resources have less to do or are needed less? I mean, shorthand answer is a lot of the times, yes. A lot of the times when I work in teams, we don't really have that traditional breakdown of like requirements analyst, business analyst, developer, tests, quality person anymore. We usually have developers and then maybe like a product lead or a business manager of some kind that's going to be able to help us understand what the requirements are supposed to be, and that we can demo to and make sure we're hitting the mark. When teams do still have quality analysts, or they have some kind of person that is like specifically designed to test, a lot of the times what has happened is we will try and work with them to create some kind of layer, whether that's automated or not automated, that allows them to write tests that then can execute as part of this automated code. So I talked about Gherkin before. Gherkin, are you guys familiar with Gherkin at all? Okay, I'll talk about it for a second. Do you know all those given when thens that I had in the code as comments? Gherkin is basically a layer that says I can write actual given when then statements, and then I can have like another layer that interprets those given when then statements and executes code behind the scenes that like matches up to those givens. So if I had a like given a teammate exists that looks like blank, there's code that is going to see that, and it's going to like call the API behind the scenes with a payload that looks like a certain way. So if you set up something like that well, and you like maintain it well, you could enable someone who's not quite as technical to go in and write tests in a non-technical way that then can be automated. I haven't seen it work super well before, but it's usually been at like a very large scale, and things get really messy. But if you are in a fairly small focused scale, I do think something like that could work. Yeah. Or there's testers sometimes move more to the front towards the requirements side, just like development. We're moving tests to the front as much as possible, right? So if they come to that side, they can actually help write all of these given when then tests for you, define what those should look like, and then it's your job as a developer to take those and turn those into test cases, whether that be one for each one or multiples for each one. Yep. Cool. Yeah, that's a tough one. Things change, and it's hard to figure out where everybody's roles fit afterward. Yeah. Awesome. All right. It looks like we are at 7:01. I saw Matt stand up in the back, so I think I'm going to be ushered off here.
Yeah, thanks everybody for coming. Feel free to stick around. Is this thing on? Oh yeah. Feel free to stick around, chat a little bit. I think there's probably some more pizza. But thank you, Gray.
Thank you.
Let's give him a round of applause.
Awesome. There is a GitHub repository if anyone wants to do this exercise themselves. It has all of that stuff that I showed you at the beginning. It looks exactly like it was before we started coding. And it's just source allies / behavior driven test.